students, welcome back to Matrices and Systems of Linear Equation. Our learning outcome today is solve the unique solution of Ax equals to b using elimination method or Gauss Jordan. So we have covered the first learning outcome and solving unique solution using inverse matrix in the previous video. So this video will be on Gauss Jordan elimination method. Okay, so what is Gauss Jordan elimination method? Okay, Gauss Jordan is the most efficient and effective way to solve a system of linear equation. So we will look into the notes. Okay, basically when we want to do Gauss Jordan, what we have to do is we have to transfer our matrix into augmented matrix. Okay, as given here, A/B. So what is matrix A and B? That is given in your linear equation. And then we're going to reduce matrix A to identity and B will become X. Okay, so basically this is Gauss Jordan. Okay, so the Gauss Jordan involves ERO. Okay, for example, solve the following system of equation using the Gauss Jordan. Okay, now let's see how to use Gauss Jordan. As given in the notes, we're gonna write this matrix as augmented A/B. So matrix A is 1, -3, 1, 1, 1, 1, 2, -1, 1. And this is matrix B. -12, 0, -8 is your matrix B. Okay, so let's try writing this in augmented form. So matrix A is 1, -3, 1, 1, 1, 1, 2, -1, 1, and matrix B is -12, 0, -8. Okay, so this is the augmented matrix that we're going to write to perform Gauss Jordan. Okay, now this is almost like ERO. So we're going to start with column 1. We're going to try to change this to 1, 0, 0, followed by 1, 0, 0, followed by 1, 0, 0. So the moment we manage to change this to identity, the augmented matrix will give us the solution for X. So basically this is Gauss Jordan. So as I have explained to you in my video on elementary row operation, okay, we will use the order 1, 0, 0, 1, 0, 0, and 1, 0, 0. And you can prepare your template as how we did for our elementary row operation. So we're going to start with 1, 0, 0. Notice that the first element is already 1. So I can skip my first step and I can go to my second step where I have to change my 1 and 2 into 0, 0. Okay, the operation is on row 2 and row 3 because we're going to skip row 1. Row 1 is already 1. Okay. Row 2 and row 3, our aim is to get it 0. So we're going to use addition and subtraction and we will be using on row 1. Just like how we did in our elementary row operation. So now row 2, the element in row 2 is 1. So to get 0, you will use minus. Same with element in row 3, it's 2. And to get 0, you will also use minus. So both the operation is minus. Okay. And the first operation, we're going to minus with 1 times row 1. And second is 2 times row 1. Okay. So I'll write down the operation here so that we don't make any mistake. So we write down our row 2. Row 2 is 1, 1, 1, 0. Okay, I'm going to minus with row 1. Row 1 is 1, -3, 1, -12. Okay. So when we minus, we will get 0, 4, 0, 12. Okay. So that's your new row 2. Now let's go to row 3. The operation on row 3 is row 3 minus 2 times row 1. So we're going to copy row 3. Row 3 is 2, -1, 1, -8. We're going to minus with 2 times row 1. So you're going to take 2 multiply with the whole row 1. So we will get 2, negative 6, 2, negative 24. Okay, so minus 2 minus 2 is 0. Negative 1 minus negative 6 is 5. Negative 1. Negative 8 minus negative 24 is 16. So that's your new row 3. Okay. Now we're gonna copy our matrix. Okay. No changes in row 1. So we're gonna copy the row 1 as it is. 1, negative 3, 1, negative 12. Okay. We got a new row 2 which is 0, 4, 0, 12. And you got a new row 3, 0, 5, negative 1, 16. Okay, students, I hope you are following. Now, if you remember our template, the next step is to change row 2 into 1. So, we're going to change 4 into 1. So, the involved operation is on row 2. So, when we are changing into 1, we will use multiplication. So, 1 over 4 times 4 will give us 1. Okay, so the changes is only on row 2. There's only one step here. So, copy your row 1. 1, negative 3, 1, negative 12. Row 2, we're going to multiply with 1 over 4. 0, 1, 0, 3. Row 3, we're going to copy as it is. 0, 5, negative 1, 16. Okay, students. So, we have managed to change this to 1. Okay, next we're going to think how to change negative 3 and 5 into 0. So, the involved operation is on row 1 and row 3. Okay, so remember student, when we want to change to 0, we will be using either addition or subtraction. Okay, so this is negative 3. That means this is going to be plus 3 times row 2. And this is plus, so it's going to be minus 5 times row 2. Okay, so let's do the operation. Row 1 plus 3 times row 2. Let's copy row 1. 1, negative 3, 1, negative 12. Okay, we're going to plus with 3 times row 2. 3 times row 2 is 0, 3, 0, 9. Okay, so when we plus, we will get 1, 0, 1. Negative 12 plus 9 will give us negative 3. Okay, next, row 3 minus 5 times row 2. So, copy your row 3, 0, 5, negative 1, 16. Okay, we're gonna minus with 5 times row 2, 0, 5, 0, 15. Okay, so when we minus, we will be getting 0, 0, negative 1. 16 minus 15 will give us 1. Okay, students. So now we will copy our new row 1 and row 3. Okay, so row 1, new row 1 is 1, 0, 1, negative 3. No changes on row 2, 0, 1, 0, 3. New row 3, 0, 0, negative 1, 1. Okay, so that's our column 2. So we have settled for column 2. Now we're gonna focus on column 3. Starting with changing negative 1 into 1. So when we want to change into 1, we will use multiplication. So row 3 gonna multiply with negative 1 so that we get 1. Okay, so we're gonna copy this template in our next page. Okay, so our matrix here is 1, 0, 1, negative 3, 0, 1, 0, 3, 0, 0, negative 1, 1. But this we're gonna multiply with negative 1, so we will get 0, 0, 1, negative 1. So let's copy this in our next page. Okay, so the changes is on row 3. So row 1 we maintain 1, 0, 1, negative 3. Row 2 we will maintain 0, 1, 0, 3. Row 3 we will multiply with negative 1. So that will give us 0, 0, 1, negative 1. Okay, student. Now our next aim is to change these two elements to 0. So one of the element is already 0. So our operation is only on row 1. So what we're going to do, okay, row 1 is 1. So we're going to minus with row 3. Okay. So row 1 minus row 3. 1 minus 0, 1, 0 minus 0, 0, 1 minus 1, 0. Negative 3 minus negative 1 will give us negative 2. Okay, no changes on your row 2 and no changes on your row 3. Okay, students, so we managed to change this matrix to identity. That means the matrix on your right hand side is your solution. So x1 is negative 2, x2 is 3, x3 is negative 1. So basically this is Gauss Jordan elimination method. Okay, so let's say we are given a question, a system of linear equation, and they're going to ask us to solve for x1, x2, x3 using Gauss Jordan elimination method. Our steps would be writing down your matrix in augmented form, where this is your matrix A and this is your matrix B. And our aim is to change matrix A to identity, and automatically the matrix B will become your solution. How to change to identity? We will use the template that we have learned in our elementary row operation. Okay, students, so I hope you can understand and also achieve our learning outcome for today, which is using Gauss Jordan elimination method to solve system of linear equation. So I will be teaching you another example on my next video. That's all for today. Thank you, students. Please submit the solution as proof of your attendance.